Hey, what's going on, everybody? It's your boy Algebra coming to you back-to-back days in this jump off. Just want to talk to you today about two variable systems of equations. If you watched the video and you did your homework and you feel like you understand the basic keywords involved in setting up this word problem, then you should be good to go and working on two variable word problems. The difference between what we did yesterday and what we're doing today is just that we're adding an extra variable in. So instead of just having the value of x, you're also going to have the value of y. But think about it for a second. When we talk about x's and y's at the same time, what are we usually talking about? We're usually talking about a graph. We're usually talking about a slope and a starting point. We're talking about patterns. We could possibly talk about substitution and elimination. But that's about it. There's nothing else that we haven't already done with these problems other than have to set them up ourselves. So don't start freaking out because the story seems a little bit longer, that the story seems on its very, very surface level that it's more complicated, because it's all things that you definitely know about and can decipher using those keywords. So I typed up some examples on this page. I'm definitely going to pause a few times so that you can write them down. And I'm going to give you again the same direction as I would use myself in setting these problems up to be solved. We will solve them also. This total video is going to take about 15 minutes. We're already 2 minutes in. So why not end the delay and just get this thing started? Here we go. First thing I want you to do, and your homework is going to have these lines already written out for you, is I'm going to give you a situation where you have to identify the two variables that you're going to use. That statement is going to be that x represents and y represents. And what I'm actually asking you to do is define your variables. I need you to tell me what we're actually talking about in this problem. This first problem says the sum of two numbers is 20. I'm going to say that the x represents the first number. It's not complicated. If it represents the first number, then y is going to represent the second number. And what that did for me is it tells me that I'm going to have an x and a y, and those two sentences that are written above are going to work together with the same two variables. Setting these individual equations up, yes, two variables should mean that you have two equations. So don't overcomplicate it. The sum is 20. X plus y equals 20. Their difference is 6. Difference means subtraction. X minus y is 6. And looking at that, it looks like it's pretty much set up for elimination right now. When you look at it, it's stacked up with the x's on top of the x's, the y's are on top of the y's. I have a positive y and a negative y. They're going to cancel each other out. As soon as I add these two equations together, I get that 2x's is equal to 26. Notice the y's canceled out. X is 13. Take your answer, plug it back in. 13 plus y equals 20. And so y has to be 7. Done. When I looked at that original problem, it told me exactly what I needed to do. I just had to have variables to get that job done. So here we go. Number 2. It says a baker makes 4 cakes per hour. A different baker makes 3 cakes per hour. But that person started with 5 cakes done before the store even opened. I want to know how long is it going to take for the bakers to have the same amount of cakes in their respective bakeries. This is the hardest problem out of all of these today. And it's the hardest problem because when you look at it, you're automatically thinking that I need to have my x variable be the first baker and my y variable should be exactly, I don't know, the second baker. But then why am I talking about cake? Why am I talking about hours? It seems to me that both of these bakers are doing the same thing, just one is faster than the other. What I'm really talking about in this problem is that I want x to represent time. Think back to your middle school science experiments. Every time that you had to go and create a graph, the x-axis was always time. If I put time in a problem, that should be your x. It's an independent variable. Nothing you ever do is ever going to stop the flow of time. The y variable in this case, said earlier, there's two things that I care about. Both these bakers, they're making cake. Y represents the cakes. So what can I say? Well, looks like I should talk about the first baker in the first equation. It says the number of cakes is equal to 4 times the number of hours. 4 cakes per hour. You remember yesterday we said that per kind of seems like we're supposed to be talking about slope. There it is. So remembering that small bit of information going into the second baker, it says there's 3 cakes per hour. Again, per meaning we're talking about slope. Y equals 3x. But this baker started off with 5 cakes. That's like your y-intercept. That's where we began this whole conversation. So again, what does this look like to you? Well, first of all, it looks like you could graph it. You could absolutely graph this. And then you would find the point of intersection. But we said we only use graphs when we have to. If you're not provided with that space, you can still solve this thing. Because of substitution, you have these two y's. You can take this 4x and plug it in. 4x equals 3x plus 5. And then you go and solve. X equals 5. That means after 5 hours, these two bakeries are going to have the same amount of cake. Two variables, x and y, are used to create two equations. If I wanted to extend this thing and ask you how many cakes are there going to be, you would plug your 5 in and just say 20. After 5 hours, both of these bakeries are going to have 20 cakes. Let's continue. A unicorn has 1 horn. Duh. Doesn't everybody have a unicorn at home? A minotaur has 2. A minotaur is a mythical creature back from ancient Greece. It was half man, half bull, 2 horns on the head. Suppose there are 15 of these mythical creatures walking around in the Forbidden Forest. Amongst all of them, there are 26 horns total. How many of each creature is in the forest? So the key phrase here is to look at that last question. It asks you about how many of each creature. What that tells me is that I need to find out the number of animals. That means I'm looking for the X and the Y, and those need to be animals this time. X represents the unicorns, and Y represents the minotaurs. So what could the two equations possibly be? Let's break it down sentence by sentence. There are 15 mythical creatures. That means if I counted them, there would be 15. Some of them are unicorns, some of them are minotaurs. I don't know which one is which. All I know is that when I add those two numbers together, I get 15. So what about the second part? It says there are 26 horns. I know it's got to be 26, but how is that 26 coming up? Every one of those unicorns has one horn. Every one of those minotaurs has two. So what that actually did is I assessed a particular value to the variable that I created first. In this particular problem, we're talking about horns on an animal. Sometimes we'll talk about the value of money, whether we're talking about dimes, quarters, nickels, or pennies. The value that you would assess to that particular variable would need to show up in at least one of the equations. And again, now that you have your two equations, you notice that because you did it in such an organized fashion, you defined your variables in a way that your work is already organized and you can eliminate very, very quickly. Multiply the bottom equation by -1. Add straight down. Your x's are going to cancel out. And you're going to end up with an answer that says that y is 11. And if y is 11, that means that x is 4. Thusly, we're still rolling. 3 times a number, x is going to be the first number, is added to 6 times another. Y is going to be the second number. So here it is, first sentence. 3x plus 6y is 18. As long as you take your time and you read it slow, it is there. All the information that you need is good to go. Second sentence too. It says 5 times the first. First number was x. 5 times the first is 2 less than the second. Let's remember what we talked about yesterday. We said that less than meant that it had to come after something. Should I be putting 5x minus 2? No, that's the tricky part. This says less than the second. That means it needs to be y minus 2. And that small tidbit is definitely tricky. And I'm stuck in a situation where I don't like the way that this thing looks. But I can make it look better. What if I move the 2 to the other side? This makes it look like I have a substitution situation. I solved it for a particular variable. I can take that thing, plug it straight back in, and then I would be good to go. I'm not going to solve this one because I want to set the last one up in my last minute on this video. Last problem. 2 consecutive integers have a sum of 49. The word consecutive means back to back. So if x is the first number, that means the second number has to be x plus 1. That means if I have 12, the next number will be 13. If I have 21, the next number has to be 22. And all I need you to do is add these together. X plus 1 equals 49. Oh man, that problem looks really, really easy compared to all the rest of these. Your answers are x is 24, which would make y 25. Homework tonight is going to be passed out by Coach Shelton. Good luck, bonsoir, have a great weekend.